to do one on the fine-tuning of the universe. I believe the fine-tuning of the universe is amazing evidence for design, and the implications are there is a designer that is outside of the universe. And as a Christian, I believe that is pointing to the God of the Bible, Jesus Christ, Elohim, okay, Yahweh, the names God's identified in the Bible by. And I think design, the fine-tuning argument, is probably one of the best evidences in cosmology, astrophysics, all those types of arguments that you could put up. And it's pretty obvious. I'd find it very hard to be a physicist in that field, looking at all the fine-tuning measurements in the universe and actually not think that it was designed. I think that would be the difficulty there. Anyway, let's go through some of these points, and you weigh up the evidence, you weigh it up, and you see, does this point to random acts, or does this point more to the act of intelligence and the work of a designer? Okay. Just as a background note, you might know that science flourished in the Judeo-Christian countries because of the scientists in those countries believing that God created the universe and that He is an orderly God of the Bible, so therefore His creation must have order. Because of that belief, they believed that that order could be studied and understood. And in fact, they actually thought the laws of science and in the universe should actually be discoverable, and it was their mandate to pursue that. That's one of the reasons God created the universe, was for them to discover and explore it. So in other countries, science stagnated, but in the Judeo-Christian countries, the founders' beliefs pointed them towards order, and so they started studying it from that perspective, and science flourished. All of the major sciences have their roots in Christianity. The founders were all Christians and young Earth creationists, actually. And it wasn't a bad thing at all, it was a good thing. I think God actually helped them in their discoveries. I don't think He hindered them. Whereas the cry of scientists today are that these early scientists were always being hindered by their belief in God. Whereas I believe it's pretty easy and obvious to see that it wasn't their belief in God that was hindering them. That was actually, their belief in God was actually encouraging them to pursue science. And Harvard, Yale, and all the universities around the world that have been founded by the Christians are testimony to that. They have, been hijacked by evolution and the naturalism people, where materialistic answers are only the Bible answers. Actually, before we get into the fine-tuning, I'd like to speak to that, actually. How reasonable is it in science to say only materialistic answers are actually viable answers, and only the acceptable answers that science will take? That becomes a tautology. Yeah. Anyway, it means they're only accepting answers that they'll accept. It's like yeah, there's no actual way of disproving that type of thinking. I think science actually should be debating those questions with different questions. If design is not allowed to be put forward as a mechanism for what science sees as the answer, then it is limited, and it is limiting itself from actual answers and actually having debate in science. And I think debate in science actually causes more breakthroughs. So, I know. The irony is that after the creationists who are the founders started the science off, evolutionists now say that the order in the universe and that's isn't from creation but by random processes. So ironically, science's foundations were based on order and by design of God. Now that order is attributed to non-orderly processes that create the orderly processes. So it's kind of ironic. Anyway, so evolution has, I think, jumped on the back of the science and has promoted what it calls, its argument is for not letting design in is because we don't want religion in. But the actual premise for not letting design in is itself a metaphysical philosophy. So they're actually following their metaphysical philosophy that we don't believe design should be allowed in. So again, both of them are a bias, and materialistic answers is a bias in itself, a bias against having answers that are designed. We can quite easily find flaws in this whole argument of just materialistic answers. A logical person could say, yes, natural science can show how mountains could be formed. But also it can be logically argued that it can't show through natural processes how Mount Rushmore could be formed. And in fact, it would be getting quite ludicrous if they try to explain Mount Rushmore by natural processes, which is in fact what evolution is trying to do at the moment. It's trying to explain things that are obviously fit more design, but they're trying to explain it away using just materialistic answers. And I think it's not a sensible way of doing it. Let's get to the fine-tuning argument. Greek scholars Aristotle and Ptolemy said the Earth was the center of the heavens. This geocentric view lasted 18 centuries. Then Nicholas Copernicus in 1543 worked out the Earth probably moved around the sun. He was a creationist, but he was suppressed. Anyway, later on, other scientists extended this view, and there was different scientists who came up with this. The scientists extended Copernicus's idea and said, making the Copernican principle, that the Earth is in no significance, is not of significance and in no privileged position in the universe. Now, I believe you cannot use Copernicus to create a principle that you use in science. I don't believe that can be extrapolated to do that. I think evidence does not support that. Anyway, and this is what the fine-tuning is going to come into. Instead of admitting fine-tuning of the universe points to a designer, they tend to use random as the answer, saying there might be a... this is the argument against fine-tuning, that fine-tuning seems to point to a designer, but whole theorists are saying there must be multiverses, that there must be an infinite amount of multiverses out there, multiple universes, and they just because all this fine-tuning seems to point to a designer, if we randomly had infinite amount of universes and we were allowed to change the ratios of these fine-tuning arguments, we're bound to get one that is just right, and they're saying that's our one. we're the one who got it. So that's the argument. So I'm going to go into this fine-tuning in depth. You can see how irrational that is. See how irrational the scientists are. Instead of just admitting design, because of the evidence, they're quite willing to create theories just to survive, just to escape theories. Absolutely not reasonable. Occam's razor. The simplest answer is the correct, should be the correct one, and in this case, I think it's obvious. Anyway, they're saying we're lucky just to be in the right fine-tuned universe, all by chance, because the precise laws are bound to happen if there's an infinite amount of universes. Now, I think, again, I think that's silly. Anyway, let's look at fine-tuning. For life to exist anywhere in the universe, there are many conditions that must exist. These conditions are so precise that changing just one of them slightly would make life in the universe impossible. So there are fundamental forces needed for life to exist, and without these principles and balances with strengths perfectly balanced, they would make life impossible. The constants of nature, they're called that if you just change slightly a bit, would get you in a universe wouldn't be inhabitable. So if you were thinking about it, just by randomly picking these constant values and these laws and principles and strengths and balances of these forces, fundamental forces, randomly, you're not going to get it randomly. It just won't work. I mean, it's the whole argument. The constants are set so precise settings that they actually are actually prerequisites for life. So they actually have to be set for life to have even a chance. And if you've studied this, you'll know that they are set so precisely that it just happens to be we're in a universe that are set up that life can actually exist. Okay, so let's have a look at a few of these. I'm going to put some charts in, some words, so you can look at them yourself. Anyway, there's the electron mass, the proton mass, the neutron mass, the atomic mass, and any change in size or ratios between these of masses will result in no atoms being able to form. You've got the strong nuclear force between them. If there was nothing there to hold the protons and neutrons together, if it was weaker or was changed slightly, the force to be weaker or stronger, the atoms, of course, wouldn't exist, and there would be no chemistry. There's the speed of light. Weak nuclear force is the opposite. The cosmological constant, gravity. Without gravity, nothing could exist. Any change, even a little bit in gravity, just a tiny change in gravity, and life would be complex life would be difficult. Like we're talking like a scientist would be impossible, but maybe small little bacteria or something like that might be able to exist if it was just changed a little bit. But basically that affects life, and nothing can exist. The actual mass of the universe is also apparently, I'm not quite sure why, but apparently that's important. The electromagnetic force in the universe, the strengths of it, you would not have any bonding between chemicals, light, and no elements would be able to be formed greater than the element number 5, boron, in the elements table. So just changing that a little bit will affect things. The gravitational force, then is Planck's constant. The carbon energy resonance, Boltzmann's constant. I don't know actually what they do. I have to have a look into that. A ratio between protons and electrons. If this is electromagnetism would nullify gravity and no object could form in space. If that was different. The exact subatomic decay rates and correct distance between stars are all very vitally important. So there's quite a few constants and there's quite a few forces that need to be perfectly adjusted. Yeah, so that's just the universe itself. For life to exist in the universe, and all of them are quite big constraints, and they all just seem to be perfectly, precisely tuned, which I believe is evidence for a design Earth. One of the interesting things that I'll get to later is that the actual universe seems to be discoverable. The structure seems to have been created to be able to be discovered. Now, if it was random, that might not actually be possible if it's random. Since it's so ordered, it does seem to appear that it's been made to be discoverable. And Einstein pointed out that that was one of the biggest mysteries, that the fact that we could understand the universe, and that formulas themselves and mathematical like equations like E equals mc squared. Is that energy equals? Yeah, it does. Yeah, E equals mc squared. It was so that they're so simple that these universes actually working on such simple equations, or relatively simple. Okay. Anyway. So the discoverableness of the universe is in fact itself an interesting argument. But anyway, we'll go to conditions just for Earth, because a lot of people think, oh yeah, there are billions of stars in our there's millions and millions and millions, hundreds of millions of stars in our galaxy alone, and there are billions of galaxies. So if there's planets around all those stars, then there must be logically millions and billions of Earths with life teeming on them if evolution happened at all. And that's their logic. Now, so how rare is Earth? And this is an interesting question. So the finely tuned conditions for Earth, life to exist on Earth. This is called the anthropic principle. That universe seems to be ideally suited for our existence. There are some interesting things about Earth itself. Just perfect conditions. For complex life to exist on Earth, there must be many conditions met that have to be perfect. Our planet just happens to have all the correct combinations, which is pretty obvious. We have to have, here are some of them. Let's see. Distance from the Sun, called the Goldilocks zone. Its official name is the circumstellar habitable zone, the CHZ zone. Anyway, the Goldilocks zone, we just happen to be in this orbit around, and everyone thinks it's like elliptical, but it's only slightly. It's nearly perfect orbit around the Sun, and it's got to be within this special distance. And when we look into a little bit on that, you'll realize, wow, it's quite lucky. Anyway, this Goldilocks, the Earth has positioned, it's eclipse though, but it's a near perfect circular orbit almost. It's perfect distance. It's not too close. 5% closer, and it would boil off all the liquid and lose its atmosphere and become like Venus. It's not too far away. If it was further away, it would be 20% further. So it's a bit further, but not too far, not in our solar system. The problem would be carbon dioxide clouds would form, gas would form, and it's in its atmosphere, and it would sterilize it, pretty much like what's happening in Mars. It would be freezing. Okay, Earth's atmosphere itself. Let's look at the conditions. It's in the Goldilocks zone. Condition 1. Second, our atmosphere itself. It just happens to be the right mix of gases. Um, it's called a diatonic atmosphere. 2 atoms in the atmosphere is needed, not a polytonic 3 gas atmosphere, which all the other atmosphere planets have. It makes the atmosphere too hot. But anyway, okay, so it's got the right mix to sustain life. It happens to be a transparent atmosphere. Again, this is important if there was a designer who wanted his creation to be discoverable. There are 70 moons and planets in our solar system. Only 7 have an atmosphere, and only 1 has the right mix of gases to produce a transparent atmosphere. Any carbon, for example, would blot out the view of the stars and make it not discoverable. Now, the planets in our solar system with an atmosphere can see the stars from their surface because the gas blocks their view. Again, even our atmosphere is perfect for man to discover and study the universe, which is interesting that life exists on our planet, and it just happens to be we have the perfect atmosphere and transparent atmosphere to be able to discover our universe. Convenient, maybe. Okay, so we'll carry on. Our position in our solar system is very important. As we mentioned, the Goldilocks zone, but also the position of our galaxy is equally as important. So our position of us in the solar system, and the position of our solar system in the galaxy, and the position of our galaxy, they're all important issues. So let's have a look at the solar system's position in the galaxy. It's just as equally important for life. There is actually a Goldilocks zone for solar systems in a galaxy. If they're too close to the center of a galaxy, they'd be destroyed, bombardments by rays and radiation from suns being sucked into the black hole in the middle, and just too much condensation of all the radiation and all the solar flares coming off all the other suns would destroy if our solar system was closer. Too near the edge, and there isn't enough heavy elements that the Earth would need, which is a totally different issue. Anyway, Earth is made up of rare elements that are rare in the outer parts of the galaxy, and so they've worked out that there's a galactic habitable zone, GHZ, galactic habitable zone, near the middle of it's 3/4 in, and it can't be inside the bands. Otherwise, if we're inside the bands, we're inside too much dust, and we can't again explore and see the rest of the galaxy. It just happens to be we're between the bands, the spiral bands coming out, and that is perfect. Not only is it perfect for us, but it's perfect for us to discover the rest of the universe, and we've got the prime real estate to look at the rest of the universe. It's necessary that the Earth is not too close to these spiral arms, because it makes it too dangerous again. So we have the best position for life and the best location for astronomical studies. The advantage of better viewing for the rest of the universe. And again, this is a mystery. How did we get such a great location? Not only the right conditions, but the best location for viewing. Okay, it's something that you should be thinking about. Anyway, the type of solar system is also important. It just happens to be the correct type of solar system we're in. That makes it conducive for life to exist. And what am I talking about there? I'm talking about a lot of solar systems have largest planets near the sun and smaller ones away, like the gaseous ones in our one, according to the nebula hypothesis. If you've studied that, and it talks about when it all apparently by gravity it forms the sun and all this and all the other planets, but there's some big issues with that, and it's got to do with things like when a ballerina ice skater is spinning around and pulls their hands in, they go into a faster spin. Well, when gas is pulled in by a nebula hypothesis, the sun should rotate faster. So it's called the conservation of angular momentum. There's not enough momentum, this angular spin on our sun. It's only got 2%. It's 99% mass of the solar system, but only has 2% of the rotation of the angular momentum, which goes against that hypothesis. But anyway, moving on. Sorry, that's just side note. Okay. Anyway, so in other discoverable solar systems, I found planets which are gaseous ones and near closer to the sun and not further away, like our one. Ours happens to be the best because our large planets are actually stopping other celestial bodies and rays and bombardment from other celestial bodies from getting us. They're like a shield. Also, they're offsetting our position as well. But we'll go there. Anyway, Earth is continually being bombarded with rays from the sun and other celestial bodies, giving off radio microwaves, infrared, ultraviolet, X-ray, gamma rays. Most of it is harmful to life on Earth, and only a small sliver of it rays necessary for life to live. So there's massive spectrum, and only 1/trillionth of a trillionth is in the range that is actually useful for our life that we use. And it just happens to be our sun, happens to be the correct type of sun, because you've got to have the correct type of sun that emits that type of mostly good rays that we need in abundance. Whereas that's not the case in all suns. Okay, so we've got the right type of sun. Lucky, eh? Yeah. So there are actually, I mean, that's just a few of them. Now, there are actually 68 different separate conditions for Earth to exist, with complex life existing on our planet. And I've got about 18 here, but there's 68. And if you think about it, it gets kind of mind-numbingly amazing. And you can realize how rare Earth actually is. It's not common at all. Okay, so we'll go with one. Galactic habitable zone. That means our solar system's in the right spot, and so it doesn't get destroyed by radiation and gravitational forces. Orbiting spectral main sequence, a G2 dwarf star. That means our sun is the correct sun. It's not too hot, not too cold. It's not too small. It can't be too small, because then we'd be closer. The habitable zone would be closer. And that actually causes problems if that happens, because that would make our planet's orbit synchronize with the sun, and if that happened, one side would be always facing the sun. So it's the perfect size. So we're actually not doing that. Yeah. So we're perfect size, perfect distance away. We are protected by gas giants that shield us from other, like comet impacts and other things. So that's perfect. We're in the CHZ, you know, the Goldilocks zone, distance from our sun, called the habitable zone. It's it can't be too close, too far away. 5-20%. I've talked about that. Anyway. We need a nearly circular orbit. It's only about 1.7% from near perfect. Mars and the other planets have an 8 to 9% variation in their orbit, which actually would ruin and cause havoc if we had that. You need an oxygen-rich atmosphere. You need a mix of oxygen, nitrogen to be able to sustain complex life. This allows good climate, liquid water, and it shields radiation. Okay, there's lots of reasons for that. Anyway, you need the correct mass. Too small a planet and the magnetic field would be too weak to shield our atmosphere, and it would that would destroy life as well. So we've got the right size planet, which is good. You need a large moon. Our moon is a quarter the size of the Earth, and it happens to stabilize the Earth's axis, which is we're at 23.45 degrees, and this allows seasons on our planet. And the moon just happens to be the right distance from us, with the right size to be able to stabilize that axis. It is pretty impressive. And in fact, if you study solar eclipses, you'll realize it's 400 times smaller than the sun, and it happens to be 400. The sun is 400 times further away. That we can, it's perfectly that from Earth we can have a solar eclipse where the moon actually blots out the sun completely, and all we can see is the radiation coming off it, which is how we've made most of our discoveries. Without that, and no moon sun has that ratio, you can't really discover anything in science from that, without that. So we're amazingly lucky. That happens to be our moon and our sun, the distance 400 to 400 is perfect that we can have a solar eclipse, and that has made many science breakthroughs because of that. Again, coincidence maybe. Okay, you need a magnetic field, so you need some sort of liquid iron core hot enough to make a strong magnetic field. The plate tectonics needs to have you need plate tectonics. You have to have a thin crust, moving plates to regulate the inner temperature, recycle carbon, mix chemicals, etc. So it needs to have that sort of setup. The ratio of liquid and water to the continents has to be right. Water cools the temperature of the planet and allows chemicals to mix and recycle. And basically, we would fry without it. It has to be a terrestrial planet. Has to have a moderate rate of rotation. Ours just happens to have a perfect rate of rotation, 24 hours to a 165 degree, 360 days. That happens to be optimal. Lucky for us, again. The rotation of the planet to the rotation of the sun is optimal on our planet. And there's amazing amount of things that happen and go wrong if that's out of sync. That's not right. Okay, just the probability of getting these 13 conditions. We're not talking about all 68 conditions. I'm just talking about these 13. Is a 1 in 3, 6, 9, 12, 6. Yeah. Yeah, it's 1 in, what is that number? 3 million, billion, trillion, quillion? Anyway, it's 1 with, yeah, I think it's 12, 15 zeros after it. It's a big number anyway. It's just for them 13 conditions to be right, 1 in that many. And that's, but there are more. Remember, there's 68. Well, 14. The Milky Way is the correct size, shape, and distance from other galaxies. Otherwise, the sun wouldn't have formed and would have a different mass. That's a big issue. The sun, so the Milky Way's position and size is important. The sun is a single star configuration, but there are many other configurations. 70% of the stars observed are binary tyranny, or they have complex ones where the suns revolve around each other. That's 70%. We just happen to get a single star configuration of the right type of star. See, these are all interesting things. We happen to have Jupiter that balances our orbits of the 4 inner planets. That's lucky. We have the best tilt for seasons and life to have diversity at 23.45 degrees. The right shape, size, so that temperatures won't be too cold or hot at night, and gravity be too intense or insufficient. And that would mean wind velocities would become too severe or inadequate. Okay, so it's just 18 conditions. And I think if you think about the 68 conditions, you'll realize how incredibly important all this is, fine-tuning. It's fine-tuning of the universe arguments, and then there's the conditions just for life on our planet, showing how special our life is on our planet and rare. But let's get back to the argument about the actual universe seems to be discoverable and be able to be studied and understood. The fact that a universe can be understood is actually strong evidence for design, not a random universe. Most people don't know that, they don't realize that the breakthrough in stellar and cosmic sciences are the results of having a total eclipse of the sun. The correct placement of this, the total eclipse of the sun, and the correct placement of our solar system in the galaxy. It just happens to have the perfect view for studying the universe. Our placement in our galaxy just happens to be the best place for viewing the universe. Lucky us. Any deeper in, we would be blocked by dust and issues like that. And for a total eclipse of the sun to occur, the moon has to be just the right size so that light is not completely blocked, or not too small so there's not too much light. Having this view of the sun, this view of the sun's rays during eclipse allows them to see the chromosphere, and otherwise we couldn't see the chromosphere, and chromosphere has helped us make the cosmological breakthroughs. It just seems to be a bit of a coincidence that the moon is the perfect size to allow stellar astrophysics to progress in exploring the universe. Solar eclipses gave the breakthrough to prove Einstein's theory of relativity, confirmed by seeing the bending of light during the eclipse exactly to the angle Einstein's theory predicted. And the only place with known observers in the universe, just happens to be the best place for observing eclipses. No other planet moons give the same eclipses like our Earth's moon does for us. Again, another fluke of nature. Or was this purposely done by a creator? That's what you've got to ask yourself. Just happens to be these same narrow circumstances that allow us to exist, provide us with the best overall setting for making scientific discoveries. And that's what you've got to question. Why? Why have we now got all the best settings that we can observe and discover, and it was all random? I think you should come to the conclusion that the fine-tuning of the universe and the rare circumstances on our planet do not fit the evolutionary random. There is clearly evidence of a designer. Now, arguing with an evolutionist over this is a little bit like me arguing with someone about the Earth being round. It is clearly obvious that it's round, and I wouldn't even bother to argue with someone about that issue. But here we have clear, obvious implications of design and the fine-tuning of the actual universe as a whole and of the conditions for our Earth. Yet, to the evolutionists, they are proclaiming random. Okay? I think is the highest level of stupidity. You make a decision on that. I'll put in some little charts and facts so you can have a look and check them out yourself.